Bismillahirrahmanirrahim. This is the second lecture of physics for class 9 from the chapter number 1, Physical Quantities and Measurements. Before we start the next lecture, let's recall the first lecture in which we studied about introduction of physics, in which I told you that physics is the branch of science in which we study about matter, energy and their interaction. The next about the physical quantities, their types, base quantities and derived quantities, base units and derived units. In this lecture, I'm going to explain you about the International System of Units, which is also known as SI units. Why do we need units? To understand which physical quantity is required or what is measured, the unit is necessarily required. For example, if I say that it's 34, what does it mean? Does it mean a mass? Does it mean length or time? For that, to explain that what this 34 is, we need unit. Means if it's 34 kg, then it will be mass. If it's 34 meters, it's length. And if it is seconds, it means it's time. So with the development in the field of science and technology, there is a need for a commonly acceptable system of units. Like the world is now a global village, and particularly to exchange the scientific and technical information, same kind of units are required. Like in many countries, for mass, they use pounds. So it was a need that there should be same single unit for specific physical quantity. So in the 11th General Conference on the Weight and Measures held in Paris in 1960, they adapted the worldwide system of measurements called International System of Units, and that is called the International System of Units, which is commonly referred as SI. And in that they describe that the unit for mass is kg, the unit of length is meter, the unit of time is second, the unit of current is ampere, the unit for the temperature is Kelvin, the unit of amount of substance is mole, the unit of intensity of light is candela. So that is how they specified the system of units for every physical quantity. The next topic that I am going to explain is prefixes. You all must have used prefixes in English, but I will tell you how and where to use prefixes in physics. In physics, we come across many physical quantities which are either very large or very small. For example, 250,000 meter, 0.02 watt or 0.000007 grams, etc. To write such quantities in the decimal forms along with the power of 10, and the SI units also have the advantage that their multiples and submultiples can be expressed in the form of prefixes. So we can define prefixes as the words or letters added before SI units such as kilo, mega, giga and milli. These prefixes are given in the table 1.3, which is taken from your book, and you can see there are some prefixes, their symbols and their multipliers. The prefixes are useful to express very large or very small quantities. For example, divide 20,000 grams by 1000 to express it into kilograms, since kilo represents 10 raised to the power 3 or 1000. There are some mathematical expressions and I have taken the above examples to show them in the form of prefixes. 250,000 meters can be written as 250 into 10 raised to the power 3 meters, which is equals to 250 kilometer. 0.002 watt is equals to 2.0 into 10 raised to the power minus 3 watt, and it is equal to 2 milliwatt. As you can see the table, milli is equals to 10 raised to the power minus 3. 0.000007 grams is equal to 7 into 10 raised to the power minus 6 grams. 10 raised to the power minus 6 means micro. You can check the table as well, which shows 10 raised to the power minus 6 is micro. So that is how you can use prefixes to convert the larger values into the smaller one and to change the smaller quantities into the larger one. Now, scientific notation. What is scientific notation? Scientific notation is a way of expressing numbers that are too big or too small to be conveniently written in decimal form along with the power of 10. So, in scientific notation, a number is expressed as some power of 10 multiplied by a number between 1 and 10. For example, a number 62750 can be expressed as 62.75 into 10 raised to the power 3 or 6.275 into 10 raised to the power 4 or 0.6275 into 10 raised to the power 5. All these are correct, but this one 6275 into 10 raised to the power 4 is preferable. Why? Because it is considered as a standard form, and whenever we have to write some expression in the scientific notation, we will choose this method. How we can write an expression in standard form? If we are having a larger number, we will consider the decimal at the end of the figures, and we have to place that decimal after first non-zero digit. In this case, we will move the decimal from right towards left. In this expression 62750, we are moving the decimal from right towards left, and we are placing the decimal after 6 to make the reading to be 6.275, and the total number of digits between the first and the last decimal are 4. So the value will become 6.275 into 10 raised to the power 4, which is a standard form. Similarly, if we are having a very small value, we need to move the decimal from left towards right, and we need to place that decimal after first non-zero digit, which is 4 here, and the total number of digits between are 4. So we will write 4.5 into 10 raised to the power 4, but with negative sign. This shows the standard form, or you can see that the value 0.00045, which is the smaller one, is now 4.5 into 10 raised to the power minus 4 second. That is how we can write the figures or the expressions into standard form. The next topic is measuring instrument. Measuring instruments are used to measure various physical quantities such as length, mass, time, volume, etc. Measuring instruments used in the past were not so reliable and accurate as we use today. For example, the sundial, as you can see the sundial in the figure, water clock, and the other time measuring devices used around 1300 AD were quite crude and were not so precise. On the other hand, the digital clocks and watches used nowadays are highly reliable and accurate. Now we will discuss about some other measuring instruments that we usually use in the physics lab. Now we will discuss about some measuring instruments, starting from the instruments used to measure the lengths. First of all, we will discuss about meter rule, as you can see in the figure. Meter rule is a length measuring instrument. It is commonly used in laboratories, used to measure the length of the objects and the distances between the 2 points. 1 meter is equal to 100 centimeter. Each centimeter is divided into 10 small divisions or lines which are marked on the ruler, and each line or each division is known as millimeter. So what is the least count of the meter rule. That is the minimum value which we used to read with the help of the meter rule, and that is 1 millimeter or 0.1 centimeter. While measuring the length or distance, the eye must kept vertically above the reading point, which is shown in the figure. If our eye will not be exactly in front of the reading, it will be inaccurate. So the precaution which is required to take while taking the reading is that the position of the eye must be exact in front of the reading. Measuring tape. The measuring tape you might all have at your homes. These are used to measure the length in meters as well as in centimeters. In the figure you can see the measuring tape. Usually blacksmiths, carpenters use it. Most of us are having these tapes at homes as well. A measuring tape consists of a thin and long strip of cotton, metal or plastic, generally 10 meters, 20 meters, 50 meters or 100 meters long. Measuring tapes are marked in centimeters as well as in inches. Now I'm going to explain you about another measuring instrument called vernier caliper. This is vernier caliper in the figure 1.6 with the closed jaws. The meter rule can measure the length or the distance up to 1 millimeter only, and accuracy greater than 1 millimeter can be obtained by using some other instruments such as vernier calipers, which means that vernier caliper can measure less than 1 millimeter. Now let's discuss about the construction of vernier caliper. It has got two jaws, one is fixed and the other is movable. It has two scales. This scale is called a main scale. It is just like a ruler starting from 0 and it is ended at 12 centimeter. Between two big divisions there are 10 small divisions, each is representing 1 millimeter or 1 centimeter. Come to the vernier scale, it has 10 divisions and each of its division is of 0.9 millimeter. The least count of the vernier caliper can be found out by using the formula. Smallest reading on the main scale, which is 1 millimeter, and the total number of divisions on the vernier scale, which are 10 divisions. So by dividing them we will get 0.1 millimeter, and the least count can be also written in centimeters to be 0.01 centimeter. Now I'm going to explain you about the working of the vernier caliper, but first of all find the error, if any, in the measuring instrument. It is called the zero error of the measuring instrument. Knowing the zero error, necessary correction can be made to find the correct measurement. Such a correction is called zero correction of the instrument. Let's see in the figure whether we are having any error in the instrument or not. In the figure we can see the main scale and the vernier scale. We have to see the zero of the vernier scale. Right now it is exactly coinciding with the zero of the main scale, which shows there is no zero error, as the zero line of the vernier scale is coinciding with the zero of the main scale. In the next figure, the zero of the vernier scale is at the right hand side of the zero of the main scale, which shows that there is an error. Which kind of error is there? Such kind of error is known as positive zero error. In the next figure, we can see it's not that visible, but they have shown that zero of the vernier scale is slightly at the left hand side of the zero of the main scale, which means that there is again an error, and this time this error will be known as negative zero error. How we can find out an error? In the case of positive zero error, in this figure we have to see the vernier scale again, that which division of the vernier scale is exactly coinciding with the main scale. Right now, I can see the 7th division, which is exactly in front of any of the division on the main scale, as you can see. So what I will do, I will multiply this division, the 7th one, with the least count, which is 0.01, and I'll get the positive error, which is 0.07 centimeter. In the next figure, we need to find out the negative 0 error, and what we have to do, again we need to see the coinciding division, and in this case we are having the coinciding division is 8th one, and the initial value was minus 0.1, as the 0 of the vernier scale is slightly at the left hand side of the 0 of the main scale. So what will we do? We will subtract 0.08, which is the coinciding division, multiply by the least count with the minus 0.1, and we will get the value minus 0.02, which is the negative 0 error. And in the correction, what will we do? This positive error will be subtracted from the end reading, and this negative error will be added to the end reading, and that is how we will remove the error from any measurement. I will tell you the steps of taking reading on the vernier calipers. The figure shows the vernier calipers. To find the diameter of a solid cylinder using vernier calipers, place the solid cylinder between the jaws of vernier calipers as shown in figure. Close the jaws till they press the opposite sides of the object gently. Note the complete divisions of the main scale past the vernier scale 0 in a tabular form. Like, we need to see the 0 of the vernier scale where it exactly lie on the main scale. Right now it's between 2.2 and 2.3, so the main scale reading will be considered to be 2.2 centimeter. Next, find the vernier scale reading. For that, we need to see the vernier division, which is exactly coinciding with any of the division on the main scale. To me, it's the 4th one, so what will I do? Multiply that 4 with the least count, which is 0.01 centimeter. Then add the main scale reading and the vernier scale reading. It's now 2.24 centimeter. And in the next step, add 0 correction to get the correct measurement. That is how the correct diameter of the solid cylinder can be measured. Students, in your syllabus, there is a practical in which length and diameter of the solid cylinder is required to be measured using vernier caliper, and it will be done in the physics lab, where you use the vernier calipers with your own hands, and that will help you out in understanding the vernier caliper more appropriately. Now I am going to explain you about another measuring instrument, the screw gauge. This is a screw gauge. A screw gauge is an instrument that is used to measure small lengths with accuracy greater than a vernier caliper, which means that its accuracy is less than 0.01 centimeter. It consists of U-shaped metal frame with a metal stud which is fixed at one end and a spindle on the other which is movable. This is a lock which locks the spindle. This is called a main scale, which consists of a hollow cylinder, and a millimeter scale is engraved on it, means each division is representing 1 millimeter. There is a horizontal line which is called as an index line. This is called a thimble or a circular scale. The hollow cylinder acts as a nut. It is fixed at the end of the U-shaped frame opposite to the stud. A thimble has threaded spindle inside it. As thimble completes one rotation on the main scale, it covers the distance of 1 millimeter along the index line. It is because the distance between the consecutive threads on the spindle is 1 millimeter. This distance is called the pitch of the screw on the spindle. The thimble has 100 divisions around its one end. It is circular scale of the screw gauge. As the thimble or the circular scale completes one rotation on the main scale along the index line, it covers the distance of 1 millimeter along the main scale. Thus, each division on the circular scale crossing the index line moves the thimble through 1 by 100 millimeter or 0.01 millimeter on the main scale. So the least count of the screw gauge can be found out by the formula. Pitch of the screw gauge divided by total number of divisions on the circular scale, which is 1 millimeter divided by 100 will gives you 0.01 millimeters or 0.001 centimeter. As we take the reading in millimeters with the help of screw gauge, so we will use this accuracy to measure any quantity with the help of it. Now I will tell you the steps to find out the thickness or the diameter of any object using screw gauge. First of all, we will find out the main scale reading. For that, we will place the object between stud and spindle, rotate the circular scale until the click sound is given by the ratchet, then see the edge of the circular scale. Where is it on the main scale? Right now I can see the 6th division on the main scale, so I will say that the main scale division is 6 millimeters. Next is the circular scale reading. For that, I will see the coinciding division of the circular scale, which means that which division on the circular scale is exactly coinciding with the index line. I can see the 70th means 70 division on the circular scale exactly coinciding with the index line. So I will multiply this 70 with the least count and the answer will be 0.70 millimeters. For the end result or the diameter, I will add main scale reading and circular scale reading and I'll get 6.70 millimeter to be the diameter measured with the help of a screw gauge. For the correct measurement of the diameter or the thickness with the help of a screw gauge, we need to add or subtract the zero error, if any. For that, we need to find the zero error. So close the gap between the spindle and the stud of the screw gauge by rotating the ratchet in the clockwise direction. If the zero of the circular scale coincides with the index line, then there will be no zero error. Here you can see the zero of the circular scale is exactly coinciding with the zero of the main scale, or you can say with the index line. So here there is no zero error. Zero error will be positive if the zero of the circular scale is behind the index line, as you can see in the next figure. In this case, multiply the number of division, which is the 18th one, with the least count of the screw gauge to find out the zero error. Here we have got plus 0.18 millimeter. Zero error will be negative if the zero of the circular scale has crossed the index line. Here it has crossed the index line. In this case, multiply the number of division of the circular scale that has crossed the index line with the least count of the screw gauge to find out the negative zero error as shown in the figure. Here 95 is written, but it's 5th division, which is exactly coinciding with the index line. It is not the 95th division, so we will count the number of division, which is 5th. We will multiply it with the least count and we will get minus 0.05 millimeter to be the error, which is negative. According to the situation, we will add or subtract these errors from the end diameter or end reading to get the correct reading. So students, I hope you understood what I have explained you today. And in your syllabus, you also has to perform the practical related to screw gauge. In that, you will find out the thickness or the diameter of the thin sheet or the wire in the physics lab. So you will get better understanding of these instruments when you will use these instruments with your own hands. I hope you understood whatever I told you, or explain you. Allah Hafiz.